thank God we have the ability to record this. So I believe just do what we can do. Then our colleagues who have the recording that they can use to keep up with what we've gone through. Okay, so I'm thinking today we will do a recap of what we did last week, and then we now finish up the R script that was sent earlier. That's what I think we should do today. So from my latest interactions with people, I don't think most of us have gone through the script. Some have, some may not have had the time. So, but so far so good. Our coding is a skill that is advisable to pick up when one has the time. So I always encourage us all to take advantage of it. Okay, so now I hope my screen is visible. Please indicate if you can see my screen. Okay, all right. I can see Dr. Basa says you can see. All right. Okay. So as I said last week, this is an interactive class. It's not like where you have to wait to the end of the class before you ask your questions or make your comments. You can feel free at any time to interrupt me and say what you want to say, because we're all here to learn, including my very self. Okay, so last week I introduced the R, and as you can see, this is my screen, my R studio. So we've understood what R is about and the R studio and the 4 panes of the R studio. The top left, is the script or the source. Then the down left is the console, which is the main R, where the main R is situated. Then okay, here I collapsed the environment pane. Let me bring it back. Okay, so here is the environment, history, connections to tutorial pane. Then the one at the right bottom is the files, plot, packages, help, viewer, presentation. So those are the environments. So just to go ahead. So we already seen how to assign values to objects. So like in this first example, the value 5 was assigned to an object X. So assigning values to objects is something that will be seen a lot in R, because when you are coding, you will have need to store some values in objects, which you call up later as you code, so that as you can see, for instance, now I've been doing a lot of code. In fact, to be sincere, I didn't even sleep last night. It was around I think around 4 that I slept, because I was scripting. I was writing a code the whole of midnight. So that's how it can be. Sometimes you can code and you forget yourself, because as you code, you see yourself solving problems, and as you can see, I have a lot of objects in my environment, because as you do, you say things and you want to call them.
Sorry, please, I have a question. I
Okay,
don't want it to, I've just been very curious about this R thing. I don't know if you're familiar with GraphPad.
Not so familiar.
But you have an idea of what it does, Abby?
Yes, I do.
So in what way? I feel this is maybe because I use GraphPad a lot. I'm very familiar with GraphPad, and I I've just been very curious as to why it seems like R is gaining ground and like it's becoming more used or more functional than just your regular statistical packages. Maybe aside from the fact that you can model stuff. So if you have this and this, you can predict what will happen maybe in the next 5 years. But aside from that, because now you're saying that you are working on a code, this, that. And I'm asking myself, which one is more efficient in terms of the amount of time you spend on it. So I've really just been curious. Maybe you can shed more light to that for me.
Okay. Yeah, just as you asked, I'm not so used to GraphPad, but I used to have been very good with SPSS. But since I discovered R, I kind of, relegated SPSS. And with SPSS, I can do quite a whole lot of things. But one thing why R is gaining ground is R is has this flexibility. And okay, like for instance, now I spent a whole part of the whole night coding and trying to analyze some data. So one thing is that like the flexibility in that you you can handle data so flexibly. I don't know how to put it in a way that it makes sense, but it's when you start that you understand it. I don't know. So, but like all this GraphPad, SPSS, even Excel. Uh, okay, then okay, you mentioned about timing. Yes, to script, sometimes it could take you time, but once you get the script, you know, the script is now serves as your skeleton. So it's just like I can write a script that maybe I can see a graph on, let's say, on a publication, and maybe the graph was drawn using GraphPad. I like this graph, and I said, oh, I would like to uh, reproduce this graph with my own data, and you can now start to script and model your code so that you have an image that is just exactly like that, or you can tweak it in different ways. So that is what just makes it interesting, because you can tweak it as just as much as your brain can think of what to add to it, what to make it. That is what you can do to the graph. Maybe that's why R is getting more grounds, and R2 can handle data. Well, I don't know, it's beyond words, but as you get to know more about R, I believe if you have the passion, you flow more with it. Maybe that's why R is getting more ground than other normal apps that we use that are used to use. I remember here in the lab, I even the other day, Dr. Gilbert also raised similar questions, because it was like I've been doing almost everything analysis with GraphPad. So what is R bringing to the table? And yeah, it was a good question, and I loved his approach to it. So I remember then even Dr. Isaac too was like, R is the intent now. That is the flow. And for him, I remember that him and Dr. Isaac, they had, Isaac is the one that usually back down. But you see his point that he's making. Dr. Gil too had his point. So Dr. Gil was like, to him, he won't spend much effort in R. But Isaac was that, for you, yes, you may belong to you belong to the old generation, but for him, generation is heading towards coding, so you can't afford to give more effort to the existing apps like GraphPad, SPSS, and all, because the world is heading towards coding. Because if you want to remain in that part, you will be left behind. Like the train will leave him. So and it makes some sense too. So maybe these are various things to it. But yes, I must still accept the fact that all these apps like SPSS, GraphPad, they have their strengths and they can still analyze data good enough. You see, they have, because I've seen what people have been doing, and it's been still cool. So yes, they are good. They are good. But R is a skill that you just need to pick up and hold because yeah, I'll borrow from the words of Dr. Isaac is the future.
Okay, so I thank you. I think I understand the angle where you're coming from. It's so, is it safe to say that if you already know how to use some of these statistical packages, it might be a bit easier for you to write codes with R?
Well, R is whatever you can make of it. That you have knowledge of other apps, it can help you. It can, especially when it comes to, because it's a matter of how much your brain can think of what to do that you know what you can do with R. Like R has, like as I am now with my years of experience in R, I can tell you I only know about 10% of what R can do. And the thing is that as each day goes by and you come to see one more thing, like wow, so this is also there. And with each passing day as enter to R, you get more and more engrossed. Well, maybe for folks like me who have passions for coding, yes. So back to your question. If you have the base knowledge, if you can use other apps very well, it can help you know what you can do with R, know what you can make out of R. Or the less you know about other apps, yeah, the less you may know what you can make of R. Let me put it that way. If you have a lot of knowledge about graph path, for instance, let's say you can see the graphs, the very wonderful graph path can produce, and you'll be like, oh, I should be able to do this. Now you now take your time and start searching about R coding patterns, and it might take you time, but by the time you get your script right, you'll be able to reproduce those same graphs and even add more to it. You'll be like, wow, I did this. This is cool. I can remember then that was last year when we are still working with before we went to Cameroon for the conference and all. Then whenever Prof sends me data to analyze and put in a Nigerian map where we sampled in various states of information, then I will use PowerPoint. I'll go to Google, just get an open map of Nigeria, bring it to PowerPoint, and then start to gradually draw the map, that will outline each state I want to highlight. But what I was like, wait, so what is this? I should be able to do this. Let me find out. And now after I found out, I was like, wow, R, I can really code this in R. And that was how I discovered that, boy, I can code this out in R. So of course, one thing with R is that it's about what you can think of, that you know what you can do with it. So I just said, okay, scripting about R. It took me some time until I got the script right. So that time is what it takes you to design the script that can give you what you want. And once you get that, boom, that's like you record, like, wow, it's done. Then with that, you can start, analyzing your data because you really have your script you can use to now do whatever you want to do. So that was how I started scripting Nigerian map, African map. I can highlight any state, any color, and just talk like that. So yeah, so still back to the question. Of other apps can really be helpful as you work with.
Okay. Thank you very much.
All right, you're welcome. Okay, any other question or comment? Be free to ask your question because it's some questions that we actually get more actually than just this. This we can easily go through the scripts in our own time, but as you ask me your questions, we're able to learn much more and share ideas. Okay.
Hello. Okay. I have something to say. Okay. Thank you, Dr. Inhanyi. In fact, R is really a wonderful, I don't know whether to call it a wonderful, is it a package for analyzing not just data, but I think even the R is someone like using not just we in the biomedical science. I believe people that are into tech, all this, they should also be using it. Use it to, what because I remember when I exposed me to Python, it was coding. I was like, that was how I just followed them to the end my certificate. But I told myself it's really a big field for me. Then, and that is computational neural. But last week when you introduced us to R, I was like, wow, this is still coding. But if I will be able to use this coding here to some extent, I don't know if I'm right calling it coding, and yet I will still be able to analyze the data I have. I think I'm now seeing the importance of R. Despite the fact that somebody can use animes, all those graph patterns, but my advice to the young ones is that still they should learn how to use these ones. I remember Isaac, I told him, okay, what do you use now to do, to analyze data? He said graph path. I said, what do you use for morphometry? He said Motic. I said, can R do it? He said, yes. Can you do it with R? He said, no. I said, so you can see your now is still this. So this R, you keep learning it. And he called it the future. I said, definitely. My future is still, I'm not in my now. And as in, my future is not now. I still have a lot to learn ahead of me. I'm just starting my research. So it's an advice. As you put a lot to learn, R, please still also get acquainted with these packages, statistical packages. Thank you.
All right. All right, thank you, Dr. Gill. These are the words of elders. When they speak here, yes, these are elders speaking from experience. So thank you for that expose. Okay. Okay. So for now we're still in the basis. So you may not be having all those wonderful things that you have heard about R. For now, we're still at the basics. So because you must get the basics right before you can now go wide or wild. So for now, so we can see our R script. At least we've learned how to assign values to objects, whether numbers or characters. Then you can use the print function to just show whatever it is that that you have stored in, to show them on the console. For instance, now I can run this X. I've saved it, and it has shown here. Also, I run this one, the John, and it has been saved, and you can also see it here as well. And I can now say print Y. Print Y. Print Y, as you can see, it shows me the John. I can decide to just say Y. Y will still print the same John. So one thing is that there are instances where you may have to use the print, and instances where you may not need to use the print. So it depends on the environment that you are in and what you are coding. In the computer world, there are always like 100 ways to do one thing, and it is so because there are instances where one may not work and we need to use the other. So it's always like that. Okay, then this is the help function. I think I explained that the last time. Then the help function can come in form of, you can use the help with the parentheses, or use the question mark, use the help, and then whatever you want to question R about in double quotation marks. It's still the same thing. There's no different ways to do the same thing. And here too, you can ask R to give the examples and all the same thing. Then here is about arithmetic operations. So R, you can do your mathematics addition, like here now. You can run the plus, you can see the answer come up here in the console. Then, oh, really? That's serious. Hello, am I audible, please?
Yes, you are. I can hear you, sir.
All right, all right. Thank you. I think I got lost at the point. Okay, so here, so now we can see line 24 and line 25. It is the same thing, addition, but you can see different ways to call up the function, whether that we use the sum function or just use the plus this, you know. So, and in line 26, I tried to use the object x. Remember, we already stored the value 5 in the object x. So here, and I said 765 minus x, where x is 5. So this command here says subtract 5 from 765 and store the answer in an object A. So that is what just happened here. So if I run this function, yeah, it won't show any error. And you can see there is A here. The A here is 760. So I can decide to just say, okay, what is A? What is A? And show me what A is, which is what 760. So that's how I've run this. And here, this is multiplication. And you can see in line 28 and line 29, it shows two ways of multiplying. So you can see there is 3 asterisk 6. That's 3 times 6. Here, we can see products of use the products function. So let's run this code. 3 times 6, can see is 18, and then the next one is still 18. So these are different ways to run the multiplication code. Then this is the division. So we use the forward slash. So if we want divided by 3, that will give us this value that you can see here. My R is Zoom is blocking this. Okay, let me move it. All right. Sorry, a minute. Okay. All right. Okay. So the one divided by 3 is 7. So that is this. As I said, R is big. Even I myself, I don't know all about R. So division, I don't know about this. There still might be more. There might even be a division a function, maybe. And R Studio is something that as you even type, it brings you options if there are any. But once you type up to 3 alphabets, it will bring up whatever, like want to say PRI. You can see these new options that of functions that can run with it, for instance. So, but I've tried to type div, don't come up. That means there is no function without those alphabets that's on with R. Okay, so line 32 now. This is raised to power. So if I say 5 raised to power 2, what would it give us? That's 5 times 5, and that's 25. So 5 raised to power 2. I think this is it ampersand or what? No, I don't know what this sign is called, but that's 5 raised to power 2. And then, okay, now the semicolon here it is used in line 34, and the semicolon is used when you want to run more than one command in the same line. Like now, if I should run this, it will give me 2 answers. To give me 2 to the power 6 and also 7 divided by 3. So let me run this. You can see it's brought out 2 answers on the console. So one is 2 raised to power 6, which is 4, and then the other one is 7 divided by 3, what to 2.3333. So the semicolon is used to demarcate different commands or operations, as the case may be, if you wish. So that depends on what you want to achieve. If you don't want to click twice, you want to click once, you can just use semicolon to do that. But if you remove it, I will surely flag it as an error. Like if I decide to run this now, you can see there's an error because R is confused. You can't, why am I saying 3 is power 6? Then speed is 7 divided by 3. So R couldn't interpret that. So it's seen as an error, and it will give you a hint of where it thinks the error is coming from, or where is the error might be coming from. So that is what it has shown here by this. Okay, so line 35. Yeah, so here, of course, we remember our primary school, secondary school, board mass. Those rules still come to play as we tell R to add, multiply, divide, subtract. Now we are saying 4 plus 3 times 5 with power 2. So of course, R will first raise to the power and multiply before it will to add, and that's why we'll get the answer we get, which is 79. So mathematicians that missed, you can do the maths and confirm if R is correct. Of course, R has to be correct. Then we have our pi. Pi is a constant. Pi is 3.141593, blah, blah, blah. So you can decide to just type pi. R recognizes that word. So it's a conserved word in pi, in R rather. So if you type pi, that is what the value is. So that word, that value has already been programmed into pi. So pi is an object in R already. So, but you can still override pi. For instance, now you can see if I type pi now, it told me now I can start to override pi. So it's start to say, okay, pi, assign this value, let's say assign 45. So if I now type pi, you can see pi has changed. So that's why I said R is flexible. I can still override I's basic commands. Okay, yeah, go ahead.
Question.
Okay.
So the way you just, let's say you mistakenly override pi and you want to change it back, do you just delete this line?
Yes. Okay. In fact, thanks for that question. That takes me to where I can delete objects I've created. Like, okay, now let's look at the global environment. You can see my environment is quite big. So I can decide to use this clear workspace. If I click this now, everything will be cleared. And once I clear here, all these objects will be forgotten by R. So if I want to delete now, like now you can see the pi.
Sorry, Dr. Yang, please, where's the clear button? Because you are sharing your screen, your face was covering. Wait, okay, sorry, don't worry, I've moved it. So where did you say the clear button is?
Yeah, can you see my purple cursor where it's moving around?
Looking like broom.
Okay, so that is
okay. That looks like a broom. Okay.
Good. Yes. Okay. Fine. Let me tap it. Now you can see my environment is quite big. If I tap here now, you can see it
I hope you saved this work. Oh.
Yeah. Don't worry. Don't worry. I can still reproduce the objects. I can.
Okay.
Yes.
You can zoom and see.
Okay. So in fact R saves your whatever you do in R. Okay, let me, and I wouldn't want to tick this button because I don't want to remove Pi's base objects, objects that are stored in Pi, in R, I mean rather, like Pi and others. That's why I wouldn't want this ticked. So I just go ahead and say yes. You see, my environment is not empty.
Oh, wow.
Now, if I
Wow.
type pi, let's see, the original pi is back. Okay. Now
Okay.
let's go back to give pi 45. If I now type enter,
Okay.
someone talking. I can't. Sorry, I can't hear it. Someone wants to talk, but I can't hear anybody.
We're not hearing you.
Dr. Chinyere, could you please unmute and talk, please? Dr. Chi, maybe you can use someone else's microphone.
Okay.
To...
Hello. All right. Hello. Can you hear me now?
Yes.
Okay. Yes. Okay. All right. I'm still confused in this pi. So that's line 36 pi. Did the pi that gave you this 3 points hash 3.1415926654? Hello?
Yes, it is. Yes, it is the base pi, as in the pi that we know in mass, which has been programmed.
The 24/7 that you use when you're calculating circumference and radius is the pi that we are talking about here, Dr. Chinyere. So that's the basic pi that we know.
Okay.
It's
Okay.
a constant.
Okay. All right. Go ahead.
Okay. Now, this is just one of the many pre-programmed objects in R. So pi, and we've seen how we can override the pi. So now, thank Dr. Basak for the question. Now, I'll also show you how you can selectively remove objects from the environment. Like now, instead of having to tap here and clear everything, I want to remove just one object, for reasons best known to me. So I will use the RM function. So I'll type RM, then open brackets, pi. Once I type enter, you can see the pi is gone. So this is a static way of removing specific objects. Now let's bring back our pi. Remember, I will tap the up button to bring up previous codes and down button to return. So let me bring back our pi. Then let me also bring up these other objects here in my script. So I'm bringing up X, I'm bringing up Y, and then A. Okay, good. Now, let's say I want to remove X and Y only. I want to leave A and pi. So I'll use my RM function, and I will now do this. I think X, Y. Let me see by an error code. Okay, good. So you can see both objects have been removed selectively from my environment. So now if I type X on my console, I get an error message that object X is not found, but my A is still there, as you can see, and my pi, which I have already pi, is still there. So that is one of the things we can do with pi. Okay. So I think we are in line 37. So here, this is the exponents function. Of course, those of us who may be concerned with Excel, and maybe even GraphPad too, because most mathematical softwares, they use the exponent function where the E is 10 raised to power, times 10 raised to power. So this 1.2 E3 is like saying 1.2 times 10 raised to power 3. So if you run that line of command, get it. So 1.2 times power 3 is 1,200. So that is what E does. And now we have line 38. This is integer division. So this is also a base command where you use percent /%. So it is an initial division where you tell R to divide, these two numbers and remove the decimal places, if any. So let's run this script. 5 divided by 3 gives us 1. Why? Because 5 divided by 3 is supposed to be 1 point something. So let's do the actual thing. 5 divided by 3, that is 1.6667. But if you use this 5% %3, it gives us 1. So it discards the percentage. So it's also a coding. So depending on what you want to do, you can. So if you don't want to use the remainders. So that's what we can do. Then line 39 is the reverse, where you only want to see the remainder and not you tell R to just return the remainder and not the integer that is produced from the division. So let's run this and see what we get. This is 2. This will be more appreciated if we say, even though the actual remainder, not just the decimal place. Like if we say, if we put it in fraction, it will be 1 whole number 2/3. So 2 is the remainder. Well, I hope you can still remember our mathematics. So it returns only the remainder. So that is what this percent function. I think in our language is called modulo division. Modulo division. So that is the R language for it. I don't know whether it's R or mathematical language, but it's used more in R to just return the remainder of any division.
Sorry,
Then
Sal. Don't be angry.
Okay. Yeah.
Sorry. So when you say returns only remainder, are you saying it rounds it up?
No.
So because I'm wondering how the remainder. Oh, okay. I get. So 5 divided by 3, you get 1. You have 2 left. So is that 2 that is giving you as the answer? Okay, thank you. Sorry. Then another question. You put 5 space divided division, percentage /percentage. Do you have to put a space between the 5 and the percentage? If you don't, will it still work?
That's why we are here. Let's do it then. So let me remove this space. Remove this space. I hope you can see my screen.
Yes.
Good. So the answer is still
okay.
there. So,
okay.
Yes.
Okay.
So
okay.
The space is just for aesthetics. So whether the space is there or not, R can recognize because the commands are distinct. It's not like in this line 34, where removing this semicolon will confuse R because it won't make any sense to R. But in other ones, space will make no difference. So like in this 1.2 E3, if we create space, there still won't be any 1.2 exponent 3. Like if I put space, I can even put like many space, then E3. Oh, R has told me that there's an error. So I think I'm wrong in this. So for exponent, there should be no space. Well, let's try it. Let me see.
Well, the beautiful thing is it will always tell you if there's an error. So
yes.
Okay.
So I think for E, there must not be any space. Yes. So I think I've just learned this too. Okay.
Oh, wow. Okay, nice.
That allows space and one that does not. So I think most of these close ones, maybe let's say 2 times 3. So you see, times allows space. So different functions have the way they behave. and these are the things why these are the things that will take you time as you design a script to do a particular function you want it to achieve. Before you create that script, you have to do a lot of debugging. As you do, you get errors, different where errors are from, correct it, you return. So until you get your script right. Once your script is done and goes the way you want, boom, you'll be happy with yourself. And that's how you keep going. That one is done. So anything you want to do again, just get the data to conform to the script and you run the code. It will be faster after that. So the rest are sine, cosine. You can see in this line 41, they also try to call in pi to do all this sine, cosine. Yeah, those are mathematical stuff. Then we have the max max function. Here you are telling pi, give me the maximum value in a set of values. We have 4, 2, 5, 1. Of course, the maximum value here is 5. So if we run this code, see, it will bring up 5 as the maximum. And same way we run the minimum, it will be 1. So then can even run the mean, so like now, when I start to run the mean of those same elements. So I'll just replace this I with there's a proportion called mean. So it returns the mean. The mean 2 is written there is 4. So you can run the sum to the product. So if we run the sum, we get the sum. Want to run the products, but we want to run the factorial. A factorial is also for those in mathematics, statistics, where you are saying like this. Factorial 4 is 4 times 3 times 2 times 1. Then you also have the square root function. So this is how you call square roots in R. SQRT. That's the function to call square root. Okay, so that's all for the arithmetic operations. We are going to another section, which is logical operations. Logical is where we deal with true and false. So it has a lot of use, But before I go into that, are there any other questions or comments on these basic arithmetic operations in R? If there is none, okay. Is someone speaking? Can you hear someone's voice?
We are not hearing.
Mr. Josh, can you increase your volume? We can't hear you.
Negative.
All right. When you are trying to assign a value to an object, you use less than minus less than, right? So I find out that you can also use equal to.
Yeah, true. Yeah, there are instances where R can allow you to use equals to, But just as I said earlier, just as we saw what happened in the use of spaces, there are places where it can work. And so like now, okay, let's try it out. Like if I say, okay, I want to create an object called Josh, and I want to assign it this arithmetic value 87 times 4 divided by 66. So it goes well, it assigns it. But there are instances where this might not work. I'm trying to, because I know I've faced that before. Let me see. There are some complex functions you might call up. I hope, okay, let's see if this will work. Okay, now let me call up this logical operation. Let me bring it down and see if it will work. Now, okay, this worked too. because this is, I've not explained what this means, but it works. So, but the thing is that equals to works sometimes, but not always. So depends on what you're working on. R can separate, sometimes R does not. But but the use of the less than or greater than works always. But the that of less than hyphen, they're assigning a function. It's always it works. So talk said talk now. So that because it's recorded so that we hear it, Dr. Mani. So that is less than. Yeah, yes, less than hyphen, where the object is on the left hand side. So that works more. Equals to still works, so you can still use it. Sure.
No, can you hear me now? All right. So if I understand you mean that can't you hear me?
I can't hear you, sir. Can you hear him? You can. Okay, sorry. Go ahead then.
Hello? Can you hear me? Okay. What I'm trying to say is that mean that less than work in all the function can, can work always compared to equals.
Yes, exactly. From my experience, yes. Right. This is 4:30. So we started a bit late. I was thinking we'll be able to finish these scripts today, but it's still a lot. But still notwithstanding, at least we've made some progress. So do we stop here? We should run a few more minutes. What do you guys think? Or do we just want to do these logical operations? The SRS. What are your comments? You have been silent.
Okay, I also those people at the well at the other side. What does it mean? Is that it interprets the function
Okay.
on the script?
Yes, thanks for that question. In R, whenever you use the hash, actually no, it's not hash button, the hash character. R recognizes whatever is coming after it as a comment. So it does not run it, doesn't see it as a command. So it's just a comment. So based on the theme I chose from my R studio, the theme highlights comments in purple. So that's why it's very important. So it's comments. R doesn't run that those as commands. It just passes by them as comments. That's why they are.
You just put it for learning sake to explain
Yes.
okay.
Yes, exactly.
Because of the function.
Yes. Anything hash, anything from hash to the right, R sees it as comments and does not run it as a command.
Okay, thank you.
Thank you.
Okay, I think okay. All right.
Maybe also that people can contribute before Dr. Yan will answer the question so that we can track it.
Sorry, come again.
If people ask questions like the one Dr. Augustine just asked, if someone from the house should try to answer the question before Dr. Yan answers the question so that we can track learning.
Oh yeah, that's a good idea. Okay, so this is 4:32. Maybe we should come to a close because logical operations it requires some brain logic because like now this line 52, what it means is that it's asking R is 4 equals to 4. So is it true or false? So maybe we leave that for the next class. So I want to thank everyone so far. I thank our SRS who is fully interested, who is fully involved. She's here by my left, looking at me. Oh yes, oh yes. No, not my right. All right, so I thank everyone for your interest in R, and we hope to make more progress and get better. I hope the time will come when we have a project and we all come together to develop a script that will shake the world, you know. All right, so thank you all. See you next time, and God bless you.
Thank you, Paul. Paul, can you hear me?
Thank you, Prof.
Next time.